Okay, so we are going to talk about factoring. Now before I actually, and like I said, we've factored before. And the stuff that we factored before are things, let me pull this up. Okay, the stuff that we factored before has been stuff like x squared plus 7x plus 12. And your instructions were to factor. And when we do this, when our coefficient of our quadratic term is 1, when our coefficient is 1, we can use the quick trip. Kevin, you need to go see Miss Jen. You do that quickly. So, when the coefficient is 1, we can try the quick trip. Yes? And that's when I put 2 sets of parentheses down. If it's factorable, put a plus, or I'm not even going to put a plus there. Put the variable here and there. And then what we have to do is we have to say, okay, what multiplies the product is this. We multiply 2 numbers to get 12, and we add 2 numbers to get 7. What multiplies to be 12 but adds to be 7?
4 and 3.
What?
4 and 3.
Positive 4, positive 3, yes? So we put a positive 4 here, positive 3 here, and this is what I call the quick trip. And now it's factored and we're done. Agreed? Yes or no? Hello?
Yes.
Okay. So we've done things like this, right? Yes? And we've even done it, and I can't think of one off the top of my head, so I may have to work one real quick for me. Let's try this, see if this works. Now, this one isn't as easy. We don't have a coefficient of 1, do we? Do we? Now, the truth is we could try to make it 1. We absolutely could. But it's not quite as easy. You guys with me? So then we use our sum and product chart. Our sum is our middle term. This is our middle term. I tend to drop the x, so I put a negative 26. Yes? Our product are these two multiplied together. 8 times negative 7. What's 8 times negative 7?
Negative 56.
Negative 56, yes? So now what we have to do, and since this is the sum, and this is the product means I'm multiplying. And of course, my bigger number is going to have to be my negative, because when I add them together, it has to be negative, yes? So, I have a negative 8 and a positive 7, but that doesn't multiply to be negative 26, does it? So what are the other multiples of 56? Okay, well let's think of it. 4 goes into it, right? 56 divided by 4. And the reason why I know 4 goes into it, does 4 go into 8? That's how I know 4 goes into it. You with me? How many times does 4 go into 5?
1 time.
And you have 4 minus, I'm sorry?
Doesn't do it 14 times.
It will go in 14 times. So I have 4 and negative 14, because my bigger one has to be 14, yes? What are the other multiples?
2.
I'm sorry?
2.
2 and what?
28.
What?
Negative 28.
Negative 28. So here's the deal. This does not add up to be negative 26, or we could say that adds up to be negative 1. I don't want that, right?
2 negative 28.
Okay. This adds up to be negative 10. I don't want that. This adds up to be negative 26. This is what I want. Yes or no? So what we're going to do is we're going to replace that negative 26 with these two terms. Yes? So, I get 8x squared, and instead of using negative 26x, I'm going to use positive 2x and a negative 28x and a negative 7. So what I did was I replaced my negative 26x with those two things. Yes? Okay, we've done this before. Now what I'm going to do is I'm going to group and factor. Group the first two, group the last two. Simple. These two group, these two group. Yes? What do these have in common? I want both the number and the variable if they have both a number and a variable. You understand? So do they have a common variable? What is it? That's the common variable? What's a variable, guys? Well, let me ask you this. Is that a variable?
No.
Is this a variable? Nice and loud.
No.
Is this a variable? If those aren't variables, what's a variable? X. X is the variable. Do they have a common variable?
No. Wait, yes.
They both have at least one x, yes? Do they have more than one x? No. This is an x squared, this is an x, yes? So they have an x in common. Do they have a number in common? Is there a number that I can take out of both those? 2. So, what's 8x squared divided by 2x? That's okay, I'll wait.
4x.
Thank you. What is a positive 2x divided by a positive 2x? 1. Very good. It's a positive 1. Yes? Hello?
Yes.
Okay. So now is a very big deal. You see that sign right there? I don't care what it is. I don't care if it's a plus. I don't care if it's minus. Do not care what it is, because whatever it is, it's coming down right there. Yes? Okay. Now let's look at these two numbers. What do they have in common? Do they have a variable in common? No, but they do have a number in common, don't they? What number can I take out of both of those? 7. Now here's where we have to be careful. I'm taking a negative 7 out of a negative 28x. What's a negative over a negative? Positive. So it's going to be positive. A positive what? 4 what? Okay, positive 4x. What's a negative 7 divided by a negative 7? Positive 1. Now I'm going to step back. Do you see anything alike right here? What do you see that's alike? So I'm going to write down that 4x plus 1. And what I do is I'm actually pulling that out. I'm factoring it out. So technically, this is now gone because I factored it out. It's right there, yes? Now I'm going to push together what's left. What's left?
2x minus 7.
And 2x minus 7. And I just factored that, yes? Right? Okay, so now that we've had a reintroduction to what we factored before using our sum and product chart and using our quick trip, let's talk about what these factors represent. Okay? If I were to set this equal to 0, yes? I set each factor equal to 0. X plus 4 is a factor, so that would equal 0, yes? X plus 3 is a factor, so that equals 0, yes? So set each factor to 0. Solve for x. Subtract 4 from both sides, x equals a negative 4. Subtract 3 from both sides, x equals a negative 3. Yes? Now, what we just found is that is where the graph is going to cross the x-axis. Do you understand me? So, this is a parabola, it's a quadratic. We've got a graph right here, yes? This graph is going to cross, this is a negative 4, this is a negative 3. It's going to cross right there. We know it opens up, so it's going to look like that, yes? So our zeros, our solutions are negative 4, negative 3, yes? Our factors are x plus 4 and x plus 3. The reason why we have to worry about factors is because we're finding where it crosses the x-axis. We're finding the solutions to the graph. Do you guys understand? Now, in the same sense, they're not always nice and pretty. These would actually look a little bit ugly. I have 4x plus 1 equals 0 if this were equal to 0 if we were solving, yes? And then I have 2x minus 7 equals 0, yes? I would subtract 1 from both sides. Then what do? Oh, wait. Divide by 4. So x would equal a negative 1/4. What about here?
Subtract 7.
Would I subtract 7?
Oh, add 7.
Add 7. Very good. We have to do the opposite. So I get 2x equals 7. Then what?
Divide by 2.
So x equals 7 over 2. Yes? So that's 3.5, and that's a negative 1/4. So if we were to think about what the graph looks like, okay? If this is a negative 1, here's 1, 2, this is 3, this is 4, okay? So a negative 1/4 is going to cross it about right there, and a positive 3.5 is going to cross there. Since this opens up, because our leading coefficient is positive, it's going to look something like this with our vertex, yes? Yes? Okay, so it is very important that we're able to identify where our zeros are, because that's how we're going to identify graphs. With that said, it's not always easy. So what we have to do here, if we look at this one, okay, this one in particular should be fairly easy. It's the quick trick, right or wrong. My leading coefficient is what? 1. So I can try to put down my little parentheses, yes? X goes in the front, yes or no?
Yes.
What multiplies? What's my product up here?
4.
Don't do that, please.
Is it 4?
It is 4. Very good. My product is 4. What multiplies to be 4 and adds to be what? What? 5. So, what multiplies to be 4 and adds to be 5?
4 and 1.
Right, and let's say our signs too. Positive 4, positive 1. Very good. Positive 4, positive 1. So far, so good? So, if I were to find my zeros, yes?
Yes.
Okay, x would equal what right here?
Negative 4.
-4, because I had to set x plus 4 equal to 0, subtract 4 from both sides, x equals a -4, yes? And x equals what right here? Very good, -1. So here's what we've just found on this one. My graph, 1 is going to be a parabola, yes? Hello? Because it's a quadratic, right? Does it open up or down?
Up.
Up, because it's positive. So I've got a U, yes? And it's going to cross my x-axis at -4, -1. Are you guys with me?
Yes.
So I'm going to kind of skip around. I'm going to come down here. That's not a parabola. Is that a parabola? Is that a parabola? Is that one? Is D a parabola?
Wait.
You're looking for a U, yes? Is D a parabola?
No.
Okay. Is C a parabola? Okay, that could be it. What about E or F?
No.
Okay, so actually C is my only parabola up there, but if we also look, it has to be at a -1, -4. There's my -1, there's my -4. C does match up with number 1. You guys with me?
Yes.
Hello? Okay. So now, I'm going to let you guys pick the next one that we do. We know that A goes with graph number C, yeah? You pick the next one. I don't care. Okay? I'm going to look at D. We can skip around. You guys with me? Okay. D's a cubic, yes? All right. All right, so maybe, maybe not. What do those have in common? What? The variables. So what's the highest variable I can take out of that? Just x. So if I factor an x out, yes? What's x cubed divided by x? X squared. What's a negative x divided by a positive x? What? No, I got a negative x over a positive x. So let's think about this. What's a negative 5 over a positive 5?
1.
Oh, is it 1?
0. I don't know.
What? It's a negative 1. So if we stop and think about it, take this out. What's 5 over 5? What's 5 over 5? It's a positive 1. Yes? So if 5 over 5 is 1, I have a negative 5, so I get a negative 1. Yes? So I get x squared minus 1 equals 0. Yeah? Hello? Okay, so now this is the difference of two squares. If you guys remember, we would have things like x minus 5 times x plus 5. And instead of foiling it out, we knew this was the difference of two squares, yes? We knew if we FOILed it out, it was going to be x squared minus 25. Because this is a perfect square, this is a perfect square, and my middle term would end up canceling, right or wrong. Okay? Same thing applies for if we had 3x minus 2 and 3x plus 2. FOIL it out, my middle terms will cancel. This would be 9x squared minus 4. Yes? Yes? Okay. Well, I show you that to bring to your attention, this is the difference of two squares, is it not? Is this a perfect square? I can wait. Is it? Yes. Is 1 a perfect square? What do I multiply to get 1? 1. 1 and 1, yes? So, it is a perfect square. So, we could do this two ways. I have this x, this one. This one's down here, it's along for the ride. This one, this right here, I have two parentheses. Since it's the difference of two squares, yes? One's a plus, one's a minus. Right or wrong?
Right.
Okay. X goes here because the square root goes right there. The square root of 1 is 1, yes? Equals 0. Right or wrong? I have 3 factors, which is what I'm supposed to have. Since this is to the 3rd power, I should have 3 factors. Everybody with me? If that was to the 4th power, how many factors should I have? 4. Everybody there? Okay. So now I take each factor and set it equal to 0. X equals 0. That's the first one. X plus 1 equals 0. X minus 1 equals 0. If I solve for x right here, what does x equal?
-1.
Thank you. If I solve for x right here, what does x equal?
+1.
So what I'm looking for are 3 solutions where it crosses my x-axis 3 times. It's going to cross at 0, -1, and 1. Do we understand that? Yes or no?
Yes.
So let me ask you, how many times does it cross here?
4.
So can that be it? No. How many times does it cross here? 3. Could A be it? It could be. Yes? It crosses 3 times. Let's continue. This is already taken. Could it be B, D right here? No. It crosses 4 times. What about F? Could it be F? It could be. Okay. Could it be E? Okay. So we have possibilities A, E, and F. Yes or no?
Yes.
Well, we have to figure out, we have to have it 0, -1, and 1. Huh. There's a 0. There's a -1. There's a 1. Brent identified it just like that. You guys with me?
Yes.
Okay. How come E couldn't be it? Because it's in a -2. And we have to assume this is a 1 by 1, yes? Okay. Questions? Okay. And we're going to identify graphs by factoring. Are you guys with me? Yes or no?
Yes.
Okay. Okay, let's look at E. Well, first let's look at F, then we'll look at E. All right? Now with F, F's a little bit different. different? What? We have 2 to the 4th power. So we're going to have 4 solutions, right or wrong. So automatically right now it's going to be B or D. Yes or no? Okay. Now the truth is when we already have the graph, we can probably figure it out. Yes? Okay. Now what I can do is I can group the first 2 and the last 2. I can just automatically start grouping. You with me? Okay. What comes out of both of these? I want the biggest number, biggest variable, biggest number.
2.
Oh, okay. Does 2 come out of here?
No.
Okay, 1 is the biggest number. Brent's absolutely right, because 2 doesn't come out of both those. So 1's my biggest number. I really don't need to write the 1 down. What about the variable? What's the largest variable I can take out? But x, just 1x?
Cube.
X cubed, because there's 3 of them here, and there's at least 3 of them there, yes? So what's x to the 4th divided by x cubed? It's x. And if you guys don't know that, there's 2 ways to do it. X to the 4th over x cubed. Cancels, cancels, cancels. I got x. Yes? There's one way to do it. X to the 4th over x cubed. Yes?
Yeah.
4 minus 3 is 1. So that leaves me x to the 1st power. You with me? Okay. 2 ways to do that. So, what's a negative 2x cubed divided by x cubed? Negative 2x cubed over x cubed. Very good. Negative 2. So far, so good? Now, same application. This is a minus, yes? So I'm going to bring that down. I don't care if it's plus, I don't care if it's minus, it's coming down. Do we understand that? Okay. So it comes, it comes down. Oops. Can't write. Can't do this today. Minus 2. Okay, then minus. What do both of those have in common? An x. A negative x squared divided by negative x. Negative x squared, negative x. What's a negative over negative? Positive. What's 2 minus 1? 1. So I have 1x, or you can think of it as x over x divided by x. You still get 1x. It's in the numerator, yes? Okay. X. And then what is a positive 2x over a negative x? A positive 2x over a negative x. What is it? What cancels? What cancels? The x's cancel, yes? So I actually get 2 over negative 1. What's 2 over negative 1? Well, it's a negative 2. We can't leave the negative in the denominator, can we? So we would multiply this by negative 1, this by negative 1. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2. Negative 2 over 1 is negative 2. Yes? Okay. So I get negative 2. You guys with me?
Yes.
Okay. So, what comes out of both of these? Oh, wait.
Negative 2.
Just negative 2? What do you see that's
X.
alike?
X and negative 2.
X minus 2 is alike. So I'm going to pull that out. You guys with me? So if I pull this out, and I pull this out, because that's what I have to do, they're common, they have to be alike. What pushes together?
X cubed.
X cubed minus x. Now, we're not finished, we still have equals 0. These have something in common, don't they? What do they have in common? X. So I'm going to hold this one over here. You with me? And actually, let me bring it down here. Because I don't want to forget about it. It's still part of it. You with me?
Yes.
But I'm going to work with this right here, flip. There we go. So if I factor an x out, I get x squared minus 1. Yes or no? Yes? So this x is going to come down here. This is the difference of two squares, just like what we did earlier. Yes or no? So this should be x plus 1 and x minus 1. Yes? Equals 0. I have all four factors. 1, 2, 3, 4. 4 factors. You with me? One of those factors, x equals 0. Another, x minus 2 equals 0, so x would be 2. Yes? Hello?
Yes.
Then I get x plus 1 equals 0, so x equals a negative 1. And then I have x minus 1 equals 0, so x has to equal 1. Yes? So my solutions are negative 1, 0, 1, and 2. I put them in order. Negative 1, 0, 1, and 2. Yes?
Yes.
So those are my zeros. Okay, this crosses at 0. Yes? Negative 1, 1, and 2. Yes or no?
Yes.
So it looks like B. Let's check and make sure. This is a negative 1. I'm sorry. This looks like maybe a negative 2. Negative 2 is not part of it, is it?
No.
So this is going to be it. So B is going to be my solution for F. Okay? Now, I realize it's Monday. You guys might be tired or whatever, but this is still stuff that we have to do. You guys understand? Okay, and I said it was F. Yeah, it was F. We did F. Okay, so what I want you guys to try to do is E. And if you need to work together or talk to each other, do so, but you try to do E. And if you need to move so you can see a little better, feel free to do that. Okay, so if we look at E, I like E for several reasons, okay? First of all, to the fourth, it could be a quadratic. Do you understand me? Because what's x squared times x squared? X to the fourth. So it could be, yes? So since it could be, I'm going to try this out. You guys with me? What multiplies to be a positive 4 adds to be a negative 5? Nice and loud.
Negative 1, negative 4.
Okay, so x squared minus 1, x squared minus 4 equals 0. Okay. That multiplies to be a positive 4, adds to be a negative 5, yes?
Yes.
Okay, so I'm on the right track, but here's the deal. That's the difference of two squares. I need 4 solutions, yes or no? Now, I could have the same solution twice, but I need 4 different solutions. So this is the difference of two squares. So this is x plus 1, x minus 1, yes? What's this? Is this the difference of two squares? Is 4 a perfect square?
Yes.
What do I have to multiply to get 4?
2.
2 and 2. Okay? So this could be x plus 2. This could be x minus 2. Yes?
Yes.
Yes? So here's the deal. This would be a negative 1. This would be a positive 1. Why I wrote 0, I have no idea. Right?
Yes.
This would be a negative 2. This would be a positive 2. Yes or no? Set each one to 0, right?
Yes.
Okay, so I have my 4 solutions. Negative 2, negative 1, 1, and 2. Yes?
D.
It's what?
D.
It is D. I've got my negative 2, my negative 1, positive 1, positive 2. Now, the whole point of factoring is to find solutions. Now, the truth is, you can punch it in your handy dandy little graphing calculator, providing you've gone through and researched and figure out how to graph it. Do we understand that? But a lot of times we don't have time to do that. You with me? Okay. So, we have discussed how to match them. Now, matching them isn't always so simple, yes, but it can be done, right or wrong.
Yes.
And if you had to show your work to match, you're going to have to factor and match. Everybody with me? Okay. So there will be some areas that it'll be required that you have to factor and match. Yes? Here, you just factor to find the x-intercepts. The x-intercepts are the solutions. It's where they cross the x-axis. Yes? Okay, I want to scroll down to these. Determine whether the binomial is a factor of the polynomial. We've done this, yes? Hello? There's 2 ways you could do it. How many?
2.
2 ways. One way is synthetic division. You can take this and put it into that, right or wrong.
Yes.
Another way is what they call synthetic substitution. What? That is where you just plug it in. Now, if I use synthetic division, I would take a -5, yes, in my little box.
Yes.
I would list them 3, 7, -8, -5, and I'd do it that way. That's synthetic division, yes?
Yes.
Synthetic substitution is exactly right. I would plug it in, yes? But what am I plugging in?
It's gonna be like opposite, right?
Right? So what am I plugging in?
You're gonna put in -5.
Right. I would find f of a -5. I would have 3 times a -5 cubed plus 7 times a -5 squared minus 8 times a -5 minus 5. Yes?
Yes.
Now, when I do all that and I get my answer, how am I going to know if that's a factor?
If it equals 0.
If this equals 0, then x plus 5 is a factor, yes?
Yes.
If when I divide my remainders is 0, it's a factor, yes?
Yes.
Okay, I just wanted to bring that back around as we have done this. Questions? Anybody? Okay, so one through 6, you have to factor it completely. Are you solving? No. So we're going to get answers, and I'm making answers up. Do we understand that? We could get answers like x times x plus 3 times x minus 7. That would be completely factored. Do you understand? Now, if I have something like x times x squared minus 1, that is not completely factored because this factors more. Do we understand that? So you need to be sure and completely factor. Show all your work. You with me?
Mm-hmm.
Okay. In 7 through 9, we are factoring trinomials, or not trinomials, I'm sorry, perfect cubes. Do we understand that? So you're going to have to go back and look what a perfect cube looks like. Are you with me? Okay. 10 through 13, you can group the first 2, group the last 2, just like what we did. Okay. 14 through 16, you've got the difference of 2 squares, because y to the 4th is a perfect square. Yes? Okay. Let's see. This is just telling whether or not it's a factor. This is telling you to find a factor. Okay? So, what your assignment is going to be is you're going to do the evens. What problems are you going to do? The evens. Now, please keep in mind, everything is going to post, but you are only going to do section 4.4, page 67. And you're going to do the evens. Which one are you going to do?
The even.
On page